Okay, so I'm moving on to example 3 on section 2.5. On Friday, we got through the first couple examples, completing the square, and I gave you the whole technique of how to do it. And I'm going to write that down real quick one more time, just in case people weren't here on Friday. Step 1 is we want ax squared plus bx plus c equals 0 order. We want that structure for the problem. And both problems we saw on Friday already had that order, so we didn't have to deal with that. This problem doesn't start off like that though, right? We got the x squared and the x equal to the constant. We want everything equal to 0. Again, we want to have the same starting point every single time. So I'm going to write 2x squared plus x minus 15 equals 0. Okay. Again, that's the first step to complete the square always. And for that matter, solving any quadratic equation. If it's the job, whether it says completing the square by factoring, we're going to learn the quadratic formula at some point. No matter what technique they say, this is your first step for a quadratic equation. Everything equals 0. Now, if I try to solve this by factoring, I'd look for two numbers multiplied to make negative 30 that add to make 1. It's factorable. Positive 6 and negative 5 do the trick. But they want us to complete the square. They want us to learn how to complete the square. So we're going to practice this technique on this problem, even though factoring would work if you want to. All right, so step 2 is divide by a if there is an a that isn't 1. Okay? So the examples 1 and 2 didn't have a number except for 1 in front of x squared. So we didn't have to do step 2 in problems, examples 1 and 2. But today we do have a number 2 in front of x squared. So this time a equals 2, I'm going to divide everything by a. So I'm going to get positive 1x squared. Now this is 1x right here, so I'm going to say plus 1/2 x. I'm going to say minus 15 halves equals 0. Let me make one quick note here just for the sake of being able to handle the technique better. Make sure you write this way. Don't put x over 2, put 1/2 x. You want to make sure there's a distinct number being multiplied by the letter x. You don't want to have x over 2. That's confusing on a future step. All right, so this is a better structure than x over 2. 1/2 x is better. All right, step 3 in the process is move constant to right, leave a gap. And I'll show you what leave a gap looks like in a second here with this problem. So the constant here is negative 15 halves. I want to move it to the right. I want to leave a gap. So here's what it looks like. X squared plus 1/2 x gap equals 15 halves. Okay, just for the sake of having neat, organized work that's going to be very systematic to the answer, that's very important that gap is there. Moving on to step 4. We're going to add b over 2 squared to both sides. Now, on Friday, b was just a nice little whole number, right? It was even, so it divided by 2 evenly, or it was odd, it just made something over 2. It wasn't that hard to deal with. Now b is a fraction. b is the number in front of x, that's b. Okay, so now, when you're dealing with fractions, there's 2 ways to make half a fraction, because that's what we're telling to do here. b over 2 means half of b. So I'm going to put a little disclaimer on this step here. I'm going to say to take half a fraction. You have 2 options to make half a fraction. Option 1 is divide top by 2. If it works, that's the way to go. Does 1 divide by 2 evenly? No. So option 1 failed on this one. So option 2, multiply bottom by 2. So for step 4, that's helpful. So if I have to take half a fraction, which I have to do in this case, anytime you make a fraction, when you divide by a, you're going to make a fraction almost every time. Anytime this is a fraction here, either take half the top if you can. If you can't, then take double the bottom. So the half of b is going to be 1/4, and we're going to square it. Again, b is just some number. If that number happens to be a fraction, either half the top or double the bottom. Don't do both. All right? In this case, half the bottom, or just double the bottom made it work. And notice I wrote 1/4 squared here. I didn't make 1/16, because on this side, my next step is factoring. On this side, my next step is adding. So over here, I'm going to say plus 1/16. And notice I left a gap on purpose. When I'm dealing with fractions, I'm going to make a common denominator. I want a little gap to make the common denominator happen.
Does the 1/16 cancel out the 1/4 squared?
1/16 and 1/4 squared are the same thing, and I have to add the same amount to both sides. But again, as far as structure is concerned, a fraction squared on this side is fine, but this side I want to actually evaluate it, because on this side I have to add these together. On this side I need to factor. So for what I want to do with things, this structure is better for the left, that structure is better for the right.
Okay.
And also, just it gives my eyes the ability to see what I'm supposed to do. Double the bottom makes 1/4. I'm supposed to square it, so there's what I'm supposed to do, and then over here actually do it. So it's just kind of like showing your work within the process of the problem without having to take up a whole bunch of space to do it. So it's a nice little tricky way to get everything in there that you need while showing your work and letting your brain wrap its head around everything that's going on. All right, so the next step, step 5, is going to be factor left, add right. Be careful with the word add. It's algebraic addition. The signs determine add or subtract. So if the signs match, we add. If the signs are different, we subtract. In this case, the signs match, right? So these I'm going to add. But I need to get a common denominator, so I'm going to multiply times 8 times 8. So on the bottom, 8 times 2 is 16. On the top, 8 times 15 is 120. So 120 over 16 is the same as 15 over 2. And this is not the common denominator structure, so I'm just going to strike that out. So on the right-hand side, 120 over 16 plus 1 over 16 makes 121 over 16. On the left-hand side, my task is to factor. And again, we're looking at a perfect square trinomial structure with a bunch of fractions in it. It might seem intimidating to us a little bit, but here's how you factor every single time in this technique. You're going to create a parentheses squared. And there's 3 holes to fill. We have something plus or minus something. And the first something is the square root of this thing. If something's squared, its square root is just the thing without the square. X squared, square root is x. This is also, in this case, the way I wrote it, something squared. Square root of 1/4 squared is 1/4. So again, as far as factoring that's concerned, that structure is much easier to work with than 1/16. That's why writing it that way is helpful. The last thing is whatever this sign is in front of the x term is what goes in between them. So the factoring technique on that is always just that. That's how it factors. When you do the b over 2 squared to both sides, you create that type of factoring every single time. We're manipulating the problem into an easy factoring technique.
But you know where it says x squared at the beginning?
Yes.
Where does that go?
It's right here.
But where's this? But isn't 1/4 squared, or is that representing that both of those things are squared?
X plus 1/4, the quantity squared. Don't write this on your paper because it's going to confuse you later. That's what x plus 1/4 in parentheses squared means.
Oh.
If you do FOIL, x times x makes the x squared. You get 1/4 x plus 1/4 x. And then you get your 1/4 squared, right? 1/4 plus 1/4 is 2/4, which is 1/2. So it's the same expression, right? But again, that's just how the factoring of that technique works, all right? So we're creating a structure that factors that way. You can believe in the factored form every time because it's going to be right. But if you need to understand where it's coming from, that's where it's coming from, all right? So our next step, step 6, is going to be square root both sides. Plus, minus on right. So here's what this looks like. We have a perfect square equal to a number. All right, the number may or may not be a perfect square, it doesn't have to be. But we have a perfect square, parentheses squared equals number. If I square root the left-hand side, the square drops off. So if I drop the square off the left-hand side, I've taken the square root of it. As a consequence, I have to take the square root of the right-hand side. I have to put a plus or minus in front of that square root symbol. Now, in fraction world, to take the square root of a fraction, you square root the top and you square root the bottom separately, if possible. If not possible, leave it under a square root. Now, I told you on Friday when we did this, and I used a really big black marker here, never, I don't know if I can fit it here, never reduce this. Put my this lowercase a little bit. Don't reduce that fraction. Because when the way we're working this out, this is always a perfect square, which makes this common denominator a perfect square, which makes that bottom a perfect square. So when you go to square root this thing, the bottom's going to be a perfect square root every time. And that's the best way for numbers to be. Square root on the bottom is exact. So never reduce that fraction there. Any other fractions up here, if they reduced, go ahead. Just right there at that one moment in time, don't reduce that fraction. So my last step here, solve for x. And you want to simplify as much as possible in this step also. So, to solve for x, I simply have to get x equals. I make that happen by moving the 1/4 over to the right. X is staying on the left. 1/4 moves over, becomes negative. Always put whatever you move over in front of the plus minus sign. So plus 1/4 moves over, becomes minus 1/4, plus or minus. Now let's deal with the square root deal here. What's the square root of 121? 11. What's the square root of 16? 4. So, negative 1/4 plus or minus 11/4. Okay, now, if that ended up being a square root expression, it's like, say it says negative 1/4 plus or minus the square root of 17 over 4. Let's say it said that. You're done. Nothing else you can do. But, when you have a regular fraction here, no square root on it anymore, added to another fraction, we should actually do the addition subtraction. So, what this plus minus means here is to add and subtract. So if I add first, what's negative 1/4 plus 11/4? Negative 1 plus 11, so positive 10/4, right? And then negative 1/4 minus 11/4 would be what?
10/4.
Negative 1 minus 11.
Oh.
That'd be 12/4.
Yeah.
What kind of 12/4?
Negative.
Negative 12/4, right? So the plus minus means to add and subtract. So again, if I add, negative 1 plus 11 makes positive 10. If I subtract, negative 1 minus 11 makes negative 12. Everything's over 4 because that's how fractions work. When you add fractions, the common denominator is what it is. The numerator gets changed by adding or subtracting. And the last thing, of course, again, this is all step 7. I solved, but oh look, I can actually evaluate this. Then I evaluated this. Oh look, I can reduce the fraction, so I'm going to reduce the fraction. So my final best answer to this problem is going to be x equals positive 5/2 and negative 3. 10/4 reduces by 2. Negative 12/4 reduces by 4. If you get to an integer answer, leaving an integer answer is better than making it over 1. So negative 3 is better than negative 3 over 1.
How do we get 5/2?
10/4 is what we had, right?
Oh.
Divide by 2, divide by 2. 12/4, negative 12/4, divide by 4, divide by 4, so negative 3. So again, and negative 3 is better than negative 3 over 1.